everyone, welcome to our math tutorial. Before we begin our tutorial today, may I introduce myself first. My name is Jan Lawrence A. ROMIALA from BSed Math 3rd year. Our topic is all about integration of calculus using power formula. What is the power rule of integration? The power rule of integration is used to integrate the functions with exponents. For another instance, the method for integrating function that can be written as a power of x, we can write it as f of x is equals to a dot x raised to n. May I introduce to you the power formula. The power formula is the integral of a dot x raised to n dx is equals to a over n plus 1 times x raised to n plus 1 plus c. The c is instance for constants. To clearly understand the power formula, let's have an example. For example, we have the integral of 2x cubed dx. To solve this given problem, we need to apply the power formula. But before that, we need to find the value of a and n. The value of a is equals to 2 in here, and the value of n is 3, which is the exponent. Now, let's solve this problem. The integral of 2x cubed dx is equals to 2 over 3 plus 1 dot x raised to 3 plus 1 plus c. How? Because we apply the power formula. And we get the 2 over 4 x raised to 4 plus c. Although we get the final answer, which is 1/2 x raised to 4 plus c. For more understanding, let's have some examples. Let's evaluate the following integrals. For number 1, the integral of negative 2x raised to 7 dx, and number 2, the integral of 4x dx. For number 3, we have the integral of 4x raised to 5 dx. For number 1, the integral of negative 2x raised to 7 dx. To solve this problem, we need to apply the power formula. And we get the integral of negative 2x raised to 7 dx is equals to negative 2 over 7 plus 1 times x raised to 7 plus 1 plus c. And we get negative 2 over 8 x raised to 8 plus c. And after that, we get the final answer. That was negative 1/4 x raised to 8 plus c. For number 2, we have the integral of 4x dx. As you can see in our problem, we don't have an exponent. But in our solution, the integral of 4x dx is equals to 4x raised to 1 dx. Always remember, any variable that they don't have an exponent have a visible one. Now, let's calculate this problem. We apply the power formula. That was equals to 4 over 1 plus 1 times x raised to 1 plus 1 plus c. And we get 4 over 2 x squared plus c. And the final answer is 2x squared plus c. For number 3, we have the integral of 4x raised to 5 dx. To solve this problem, we need to apply the power formula. So we get the integral of 4x raised to 5 dx is equals to 4 over 5 plus 1 times x raised to 5 plus 1 plus c. So we get 4 over 6 x raised to 6 plus c. And our final answer is 2/3 x raised to 6 plus c. This is the last of the problem. I hope that everyone will understand the integration of calculus using the power formula. Thank you and God bless.
Hello everyone, my name is Jeffrey Castillo and today I'm going to teach you how to integrate exponential functions. So our topic for today is integrating exponential functions. Alright. So our objective for today is to evaluate the integrals of exponential and rational functions. So for the exponential functions, we have questions here. What does the integral of e raised to x dx is equal to? And also, what's a function whose derivative is e raised to x? So our formula for this function is we have the integral of e raised to x dx is equal to e raised to x plus c. You can notice that we did only copy the constant e raised to x, then we add a plus c. We add plus c because we are in indefinite integration. So our exponential integration, same thing, we have e raised to u du is equal to e raised to u plus c. Alright, for the example number 1, we have here evaluate the integral of e raised to 3x plus 1 dx. So the next step, we have to let u is equal to 3x plus 1. And so we can rewrite the integral into dx is equal to the integral of e raised to u dx. And then we want to find the derivative of u, that is a 3 dx. And then we're going to divide both sides by 3 so that we can get the dx. So we have the result of 1/3 du is equals to dx. And so continuing the integral, we have e raised to u, just copy that and then substitute 1/3 du to our dx. So we get integral of e raised to u times 1/3 du. And so according to the rule of integration, we need to write 1/3 before the integral sign and then just copy the e raised to u, then add du. And so we're going to multiply 1/3 to e raised to u, we get 1/3 eu, and then we add plus c because that's our indefinite integration. So our final answer, we need to substitute u in 1/3 e raised to u, we need to substitute back the u, so we get a final answer as 1/3 e raised to 3x plus 1 plus c, and that is our final answer. Alright, the next example that we have here is the integral of 10x raised to 4 plus 4x, and then x raised to 5 plus x squared minus 1 dx. So we're going to test which of these will be the u. So take the derivative of the choice of u. If you cannot find it elsewhere in the integrand, then use a different expression for u. So we're going to test. So what happened if we let 10x raised to 4 plus 4x as our u? So our derivative would be 40x cubed plus 4 dx. But if we use x raised to 5 plus x squared minus 1, we get the derivative of u as 5x raised to 4 plus 2x dx. Therefore, that would be our u, and that is, this expression is off only by a constant multiple. So for the solution, the integral of 10x raised to 4 plus 4x, since we know which of this will be the u, we can continue to our solution. So as we let u is equals to x raised to 5 plus x squared minus 1, our derivative for that is 5x raised to 4 plus 2x dx. Of course, we rewrite the integral into dx is equal to the integral of e raised to u times 10x raised to 4 plus 4x dx. And then we're going to find the uh, dx, so we need to multiply both sides by 2 to get 2 du is equals to 10x raised to 4 plus 4x dx, that later will be substituted to our integral. So our answer is integral of e raised to u times 2 du. Then according to the rule of integration, we need to put 2 before the integral signs, and we'll be left with e raised to u du. And now we can multiply 2 times e raised to u du, and we're going to add plus c because we are in indefinite integration. So our final answer would be 2e raised to x raised to 5 plus x squared minus 1 plus c, because we substitute back the value of u. And that is our final answer. Conclusion: integration by substitution is a technique for finding the antiderivative of a composite function. Experiment with different choice for you when using integration by substitution. And also, a good choice is one whose derivative is expressed elsewhere in the integrand. Okay, thank you for watching. Again, this is Jeffrey Castillo. I'm a BS Ed Math third year.
Our topic for today is all about the trigonometric substitution. We can use the right triangle in the Pythagorean theorem to simplify some problems. For example, number 1, the integral of dx over the square root of 4 plus x squared. As you can see, we have the right triangle here at the right side of our screen. It represents the Pythagorean theorem. It has a hypotenuse, adjacent, and the opposite. As you can see, the denominator of our given function in the hypotenuse of our right triangle are in the same form. Now, we can use the Pythagorean theorem. Then substitute the value of a becomes 2 and the hypotenuse for a square root of 4 plus x squared is our hypotenuse. Now, second theta is equal to the square root of 4 plus x squared over 2. 2 second theta is equals to the square root of 4 plus x squared. Tangent theta is equal to x over 2. 2 tangent theta is equals to x. Now we have the value of x. 2 second squared theta d theta equal to dx. Then substitute the trigonometric function in our integral. The integral of 2 second squared theta d theta over 2 second theta. Just simplify the equation. We just cancel 2 second theta, and the integral of second theta d theta ln second theta plus tangent theta plus c. Ln the square root of 4 plus x squared over 2, which is the value of our second theta, plus the x over 2, the value of our tangent theta, and then add our constant c. So ln the square root of 4x squared over 2 plus x plus c, and then we get the final answer, which is ln the square root of 4x plus x squared plus x minus ln 2, ln the square root of 4 plus x squared plus x minus ln 2 plus c, where my negative ln 2 is a constant. Then we get the final answer, ln square root of 4 plus x squared plus x plus c. This method is called the trigonometric substitution. If the integral contains the square root of a squared plus x squared, we use the triangle at the right. If we need the square root of a squared minus x squared, we move a to the hypotenuse, just like in the picture. If we need the square root of x squared minus a squared, we move x to the hypotenuse of our right triangle. The use of trigonometric substitution is to evaluate integral involving radicals. Square root of a squared minus u squared, the square root of a squared plus u squared, and the square root of u squared minus a squared. The objective with trigonometric substitution is to eliminate the radical in the integrand. You do this by using the Pythagorean identities. Cosine squared theta is equal to 1 minus sine theta. Secant squared theta is equal to 1 plus tangent squared theta. And tangent squared theta is equal to secant squared theta minus 1. Let's have another example. The integral of x squared dx over the square root of 9 minus x squared. We have right triangle here. 3 is our hypotenuse and our adjacent is the square root of 9 minus 3 and x is our opposite. The sine theta is equal to x over 3. 3 sine theta is equals to x. Now we have the value of 3 cosine theta d theta is equals to dx. Cosine theta equal to the square root of 9 minus x squared over 3 and 3 cosine theta equal to square root of 9 minus x squared. So substitute the trigonometric identities to the integral. And then simplify the integral. Cancel the 3 cosine theta and then we get the answer of 9, the integral of 1 minus cosine 2 theta over 2 d theta. 9 over 2, the integral of 1 minus cosine 2 theta d theta. 9 over 2 theta minus 9 over 2 times 1 over 2 or 1 half sine 2 theta plus c. Sine theta is equal to x over 3. Theta equal to arc sine x over 3. Now we have the value of theta. Then 9 over 2 arc sine x over 3 minus 9 over 4 times 2 sine theta cosine theta plus c. As you can see, this is the double angle formula. 9 over 2 arc sine x over 3 minus 9 squared times x over 3. And then we get the final answer of 9 over 2 arc sine x over 3 minus x squared, the square root of 9 minus x squared plus c. Thank you. Okay, that's all. I hope you learned about our topic for today, the trigonometric substitution. Thank you.
A pleasant day to everyone. I am GLAYZEL TABI, and I will continue the discussion about our topic about the integration in Calculus 2. And today I will discuss and give some examples about the integration of logarithmic functions. So, what is logarithmic functions in integral calculus? The integral calculus, a logarithmic function of the ln of x, can be expressed as the integral of ln of x dx is equal to x ln x minus x plus c. By use substitution, if the integral of u raised to -1, it is equal to the integral of du over u, and the answer will be ln, the absolute value of u, plus c. Integration of logarithmic functions by u substitution. So we have here the formula. If u is raised to -1, so therefore it will be the integral of du over u, and the answer will be ln, the absolute value of u, plus c, where u is not equal to 0. Always remember that. For our example number 1, we have here the integral of x raised to -1 dx. So the answer will be the integral of dx over x, it is and equal to ln x plus c. So as long as this one, u raised to -1, it will be du over u, right? So therefore, if x is raised to negative 1, it will be dx over x. So as we have observed, x is raised to negative 1, it will be 1 over x. So 1 over x times dx, it will be the integral of dx over x. So that's it. To further understand about the logarithmic functions by use substitution of in integral, we must evaluate the following. So the integral of dx over 7x plus 3. So first, let u will be the 7x plus 3. Then next, we must find the derivative of u. It is equal to 7 dx because 3, it can't be derived because it is a constant number and it is equal to 0. The next, we must find the value of dx. So we must divide both sides by 7 to cancel this one. So therefore, our dx will be du over 7. Now let us substitute the value of dx above here. So therefore, it will be the integral of du over 7 over u, which is our 7x plus 3 is u. And it is equal to 1 over 7, the integral of du over u. So if we simplify du over 7, it will become 1 over 7 du. So therefore, we must to put out the 1 over 7 here. Then, according to the formula a while ago, we must copy this 1 over 7, then add ln, the absolute value of u, plus c. So, the next, let us substitute the value of u. So, our answer will be 1 over 7 ln, the absolute value of 7x plus 3 plus c. It is plus c because this integral is what we call the indefinite integral. That's all. Thank you.
Good morning, everyone. I'm your tutor for today's video. I'm SHALYKA GARILAO, a BS Ed major in mathematics student, third year. So our lesson for today was all about the calculus under the indefinite integral, but we're focusing on integration by parts. So what is integration by parts? Integration by parts is a special method of integration that is often useful when two functions are multiplied together, but is also helpful in other ways. So you will see plenty of examples later, but now let us see the rule. So here's the rule for integration by parts. The integral of u dv equals to uv minus the integral of v du. So to clearly understand, we have an illustration here. So this read as the integral of uv dx equals to u, the integral of v dx minus the integral of u prime times the integral of v dx, where u is the function of u of x, v is the function of v of x, and u prime is the derivative of the function of u of x. So this diagram shows the rule. So let's have first our first example. Our first example is the integral of x e raised to x dx. So step 1, we should choose a u and v differently. Our u is x, our v is e raised to x. Step 2, differentiate u and integrate v. So the derivatives of x is 1 dx, and the integral of e raised to x dx is e raised to x dx. So step 3 is we should put it together in the diagram. So we have here the x e raised to x minus the integral of 1 times e raised to x dx. So next is step 4 is to simplify. We have x e raised to x minus e raised to x plus c. That is our final answer. So note, the rule is integral of u dv equals to uv minus v du. Example number 2, we have the integral of x cosine of x dx. So step 1, choose u and v differently. So our u is the x and our v is the cosine of x. And step 2, differentiate u and integrate v. So the derivative of x is equals to 1 and the derivative of cosine of x is sine of x. Always remember the trigonometric identities. Step 3, put it together into the diagram. So we have x sine of x minus the integral of 1 times sine of x dx. So simplify, we have the x sine of x plus cosine of x plus c. So note that always remember the trigonometric identities when we're integrating a trigonometric function. So that's all for today. Reminders, our steps. Step 1, choose u and v differently. Step 2, differentiate u and integrate v. Step 3, put u prime, and the integral of v dx into the uv minus the integral of v du. And step 4, simplify and solve. So, about choosing u and a v story. So choose a u that gets simpler when you differentiate it and a v that doesn't get any more complicated when you integrate it. That's all for today. Thank you for watching. Bye!